I should start?
Yes, we can start.
Okay. Okay, so good morning to everyone. I already had a chat with some of you, but not
Good
all.
morning.
Are you listening okay? Otherwise, I'll put my headphones, but I prefer to do it like this. If you hear, well,
Everything is okay.
I'll go like this. Okay. So, thanks for being here. Today, I will try to share with you some of the work we do in terms of nature-based solutions for environmental challenges, and I'll go mostly to the water sector. So this is a part of the research we do at the university. It's probably the smallest part, and most of the research is not done on site because we've got to have this kind of solutions implemented where they are needed. But it's one of my favorite subjects. Not what I do most, but one of my favorite subjects. And even for teaching, it's something that I really like to do with the different courses. So what I'm talking about is actually solutions based on nature to tackle some of the problems we have in terms of sustainability, mostly the environmental sustainability. But this nature-based concept, which is something that should not be, or it is not really new, it's something that's been there all the time. It's combining the ecology and engineer in a way to achieve these sustainable development goals and the societal goals that we're facing. So you can find a lot of definitions around these nature-based solutions, but they're mostly building with nature as opposed to other approaches, which is building in nature or building against nature or using nature. So we're actually using nature to support the economic growth. At the same time, we are doing the environmental part, the ecology, and not forgetting the economic growth. There is a range of publications that are very interesting, and I always try to look for these reports of international organizations, and I just put this one here, Nature-Based Solutions for Water, and it's a really nice guide, and it's not really very much deep in technically, but it's a really nice guide, and it comes to this concept of promoting the biodiversity at the same time as we're looking at facing this or tackling these water challenges. And this is one of the, if you remember, for those who were here last time, we talked about these planetary boundaries. Biodiversity is one of the one that has exceeded the genetic diversity, the threshold. So if we can incorporate these solutions that promote biodiversity in other sectors and not take it so much in compartments, then we can do it. So for the water, nature-based solutions, they are also designed as the NBS, really a way to address many of the challenges that we are facing concerning sustainability. And when we talk about nature-based solutions, we have to talk about ecosystem services, because it's really what we're talking about. We are going to talk about plants and the greenery, and it's really what they can give us for free, let's say, if we keep the biodiversity. So it's not only biodiversity, it's water, it's energy. We'll look at this. So when we're doing this or looking at these nature-based solutions, we're looking at this concept of ecosystem services, what we can get from nature. And as I said, it's not only plants and aesthetics. It's not only biodiversity, it's also water quality, air quality, efficiency of using the resources. One of the big things in terms of urban context, for example, is reducing the urban heat island, is the noise reduction, flood mitigation. That's what I'll talk about today as well. So it's not only plants, it's not only biodiversity, it's trying to incorporate plants in a way that we get services for free from the ecosystem. And if you're looking into what could be a constructed environment, we're talking about more natural things like city parks or a woodland, but we're also talking about green roofs on top of buildings. And it's not to look nice, because mostly you don't see them if they're just doing their technical services. We're talking about wastewater treatment. I don't see, maybe we don't see any here, but this drainage kind of ponds that you put at the soil level, they are also doing water purification, even the roofs on top. It's green walls. So there are different solutions. Some are more easy to implement and less costly. The other ones, of course, if this is an investment in nature, they are you have to invest in this then to get your rewards. But these are the so-called blue and green solutions incorporated in the, especially in the urban environments. We'll see in the example, but it's one of the problems we're facing is the permeabilized urban environments, so the water cannot go through. And that's why we're talking about flood retention. And these greenery services can help a lot. So I'll just go to two case studies that we've implemented at our university. If you wish, and if it's allowed for me to say this, you can interrupt me through the conversation, because they will be, I was just looking at how we did things. The first one is an example on constructed wetlands for wastewater. This is not only for wastewater treatment, it's also for water runoff treatment, things like from roads. And it's also, and lately looked at also for buffer zones for from agricultural production areas. So you get to have very much a diffuse pollution through agriculture, leaching of nutrients and organic, sometimes organic compounds that are pollutants. And what you can have is buffer zones that are a barrier between the agricultural zone and the water resources that are most of the times nearby these big agricultural areas. And even in this concept, we have incorporated the circular economy approaches, because people that are looking at buffer zones from agricultural production, they're using plants that could be of some benefit, so as biomass that can have further applications. By trying to combine all these. But constructed wetlands are actually mimicking the natural wetlands. But we're just, that's why they call constructed. We are going to engineer these natural wetlands in a way that they can be used for water treatment in a certain place. But they actually mimic what happens in nature, which is a combination of vegetation, The soil, and here I have substrate because in constructed wetlands, you do not use soil anymore. They used to be used, but it is a substrate for the plants to grow. And of course, the below ground biodiversity, the microorganisms, which are in fact what are the workers, the leading cause of degradation of the pollution or of mitigation of the organic load that goes in the waste water. So what we're doing is just mimicking the biochemical cycles within the wastewater treatment. This can be used in different countries, and as I said, it has several applications: buffer zones, municipal and domestic wastewater, industrial wastewater, runoff, leachates. They have been used everywhere, and maybe if you don't want to say anything now, you can let me know in the end if you know them or if you have them installed in your own countries. We've got about 4,000 in Portugal. Not much for the type of climate we have. They are more prone to be more efficient in warmer climates. They're more used in the Nordic countries, actually. They work when it's snowing, although slower, because the microbial activity goes anyway underneath. So they are probably the less technological or the less costly solution for wastewater treatment in terms of construction, operation, maintenance. They are very tolerant to flow fluctuations, which happens many times. If you have a wastewater treatment in your own city, one of the issues for it to be operating well is that you always get to receive the same flow. So you have to have equalization tanks. But they tolerate that. They integrate well into the landscape, and they have multiple functions because they allow for these ecosystem services, including biodiversity and purification of the water. I put here ornamental features because it's the example I'll be giving has to do with this. Of course, there is a big drawback that I should have here. They take space. So it's the biggest thing. You really need space to put this. But you can use it just as scheme. You can use it to treat the water. For those who ever heard about this as the secondary treatment, this is just the main treatment, the main biological treatment of wastewater treatment plant. You can use it, the constructed wetland, to treat the flow, or you can use it after the main treatment, just as a polishing step to take the rest of the nutrients. And you're growing the plants on it, so you are doing biomass production, contributing to carbon sequestration and to further uses of the biomass. I'm not going to go much into detail of all the types that you can find. I'll just use two of those that will support the example, because you have free floating, submerged, immergent. And I'll be looking at this immergent, macrophytes, constructed wetlands. You can have three types: free flow, horizontal flow, and vertical flow. And if you look at this scheme, this is an horizontal flow. This is very simple to look at. You just have a compartment or a tank where you have a substrate. Many times this is like expanded clay. These are the things that you use for gardening that supports plant growth. It could be sand, you can use stones. Basically, you use what you have available, as long as it supports plant growth and allows a good drainage of the water. So the water goes in, comes out, and while passing through the rhizosphere of these plants, the organic matter is degraded. Some of it is taken up by plants. So you're actually sequestering also nitrogen and phosphorus in this biomass of the plants that you can use then further for composting or ornamental, whatever energy. But you're actually giving a niche of biodiversity while you're treating the water. You can also have the vertical flow, and the only reason I'm showing this is more complex vertical flow, because you actually need a prior tank to store the water. And then what you do is you fill the tank, then you close it, wait for 3-4 days, and then just drain the water and fill again. It's more complex because if you are filling the tank and then closing it, you must have another tank for the water to wait and come again. So this is more complex, but this is very useful if you need more oxygenation, because when you are filling and draining the water, then you're actually oxygenating the system. There is nothing else here. There is not much technological compartments here. There are no pumps, most of it. The water just flows. That's why it's so low cost and less energy demanding. And you, of course, this is not a hole. You must have an impermeable layer. I'll show you some. They really integrate into the landscape. This is one example for a winery. And it's mostly what you see here is Phragmites, is the plants that are mostly used for that. This is an horizontal flow bed, integrates well and allows for reduction of the main contaminants. Just for curiosity, if you're not in this field, this does not mean much to you, but this is the measure of organic matter. You see the inflow and the outflow. Usually you have 100 as the ppms as what you can discharge. This is in the Czech Republic, wastewater treatment for domestic wastewater for 50 people. Roughly, if you want to know the size, it's like you should give 1 square meter per between 1-5 people. This is used for up to 10,000 people, usually not much bigger. So these are solutions for low settings. Okay, this is just another one. This is one constructed wetland in Denmark that is used just to treat the water that comes from the drying of the sludge of the main wastewater treatment. And the reason why I think this is a nice picture is that it allows you to see that you do need space. It takes a lot of space if you're talking about big quantities. This is a constructed wetland in the airport at Heathrow. This is an example of runoff water. You have also the Phragmites, and the water is treated. And now I'll come to our example of a constructed wetland. This is the setting. This is actually a picture of the setting. Is in a tourism house and is treating the water from the tourism house, the wastewater that is produced in the cleaning, in the production of food, in people that are doing overnights there. And this is very good for, this example is rural context, where you can have many people have septic tanks. And then if you know this context, usually then you have to drain the septic tank once in a while. Instead of that, you can have a constructed wetland to treat the water. So this is where we put it. This is the house. We've worked many years in wastewater treatment with constructed wetlands for the industry. This was our first example for domestic wastewater. So this is the house. They produce vineyard. They have vineyards here. You'll see in another picture. But we try another constructed wetland for the vineyards, for the water from the vineyards, and the constructed wetland was put here. There was no sewage network, so it was the alternative wastewater treatment that they saw as feasible to be implemented here. So this is the place. Is not too big. This is about 70 square meter, and the water is produced in the house. So the reason to show this is that there are no pumps. The water comes down to the septic tank. So the constructed wetland is here. The house is here. This is the dimension. This is all the farm. These are the vineyards, and this is where we put it. So no energy, just everything comes through gravity. The house can have between 60 and 40 people. So as I said, this tolerates the difference in the flow, and we use it for the domestic wastewater coming from all the facilities, the black from the toilets, and from the gray water from washing the clothes and from cooking, everything. So this was the type we decided, horizontal flow. One of the issues is usually the insects, mosquitoes, and you have to construct your wetland in a way that the water, if you see in the blue here, the water level is not at the top, because if you have water in the surface, there might be some larvae just proliferating, and then you get the insects and you get also the odors. This is a tourism house. We had this running for 10 years, and the tourists are there. So people are going there. There's no smell, and there are no insects. And we decided, because this was a farm and it was domestic wastewater, to use the ornamental plants that they had around. So we did not go for those Phragmites that you've just seen, which are very, very tolerant to pollution. We tried the different plants that they had in the house. So we decided for those plants. I have to say we tried all the plants. Not all were able to stand the organic load. We decided on the place. You start by digging a hole. Usually this is about 50 centimeters deep, 50 to 75. It's not much used to do it at a bigger depth, because what you want is to get the roots. You want to get water through the roots where the microbial activity is higher. So there's no point in doing it very deep. You don't want dead zones. Then you just prepare for the impermeabilization. It's most of the times the thing that is most costly. Depends on the country you are. So we got a kind of a professional impermeabilization of the wetland with a geomembrane, geotextile. Then in this particular one, we decided on the expanded clay with a certain granulometry. We've used this expanded clay for a long time in the constructed wetlands, and we mixed with sand. We mixed with some sand. Sometimes it's more costly to have the sand if you have to get it from a distant place. Then it's prepared, so you just have to plant. And of course, there are the tubings going through to do the water. This is the place that goes in. Now the word is missing in English. But this is the entrance of the wastewater. It comes underneath from the septic tank. Planting is always everything looks bad. So we use, as I said, a mixture of plants. We had to plant in summer. We had some delays in people coming through to do the work for the filling and the impermeabilization. So it was like that summer was like 40 degrees. So I thought this was going to be a disaster. But then plants start appearing. We connected the wastewater treatment plant. This seems a different wastewater treatment plant, but it is exactly the same one. It's just because we use the polyculture. Depending on the time of the year, you get different colors. You see here a mixture of the plants. This is the same plant. It really depends on when you take the picture. You get it yellow or red. The plants grow. They grow a lot, actually, because they are getting the organic nutrients through the wastewater. Sorry, this is just one side by side, so you can see it is the same, but with the different times of the year. But I was saying they grow a lot. You can see how they grow because you have someone here. You can walk through that. As I said, we leave the water at about just a few centimeters underneath. You put some slope just so you keep it at a certain level, but they grow a lot. We cut it once or twice a year. And then this biomass, in this case, goes for composting. During the year, the plants are used to, by the house, to just as ornamental plants. You see the vineyards here, that's where they produce the wine. And we have a model, one that we haven't studied so much here, to collect the water from the vineyard, from the wine production during the September, October, when they produce. So this is what you get in terms of reduction of organic matter. You see the concentration in the chemical. Okay, this is a measure for those who don't know. This is just a measure of organic content, and you get a reduction, a very big reduction of the loads to levels that are allowed for discharge. So this is about 450. It goes to below 50 for the concentration, and it allows for the reduction of the phosphate and the ammonia, which are the main nutrients in the wastewater. And you can, without an input of energy and just with the people from the house to cut the plants, you get to treat a very high amount of wastewater in an energy efficient way. We look at several things in this wastewater treatment plant. I didn't bring it all in today, but we look at microorganisms. We look at microbial communities in the plants because they use it for ornamental purposes. We look at Listeria, Salmonella to see whether there was an uptake of the plants. There were several parameters, but basically what they are doing there is doing the wastewater treatment and also promoting biodiversity. We also like to go there and take pictures of whatever comes through. Here you can see well what the expanded play looks like. Let me see if this, oh no, I cannot do this. This kind of, how do you say? It looks like, probably you've seen it in all the gardening shops. It's just very porous, and you get different types in terms of granulometry, and allows allows very well the drainage. Of course, it also allows for the microbial assemblages to be formed, but you get a lot of biodiversity. So it means the water is actually clean and with low toxicity. Further to that constructed wetland, a few years after constructing it, we also decided to do kind of a pond that could be used as water storage, but also for further polishing. because the water goes to the water that is treated goes to the vineyards. It's just used for irrigation of the vineyards. So this is an example of a nature-based solution applied to the wastewater treatment sector. And you can then extrapolate this. This is a tourism house. You can have an industry. We have for slaughterhouses together with domestic water in the south of Portugal. I know them are not been involved in those. We have for industrial. There are a lot of applications. They are not a solution for everything. You need space, but there are a solution for many of the situations where you don't need then to spend so much energy, and where you can treat water, because in many places the only thing is that going to happen is that you're not going to treat water. That's it. So this is a repetition. The pond allows better for this circular economy. That's why we do. Now, just very briefly, the second case is the green roofs. And the green roofs, it's also a nature-based solution that is very much good for urban contexts. And it is also a way of promoting the reuse of non-potable water, or the use of non-potable water. That let's say people don't put this solution to treat the wastewater on top of the houses. They put it to harvest the rainwater. And it's not only about using water. Let's see. So there is a lot we can, if you have the water, if it rains, 50% of the water that we use in our houses, there was something that I also showed last time, can be replaced by non-potable water. So we could save a lot of the water that comes through our tap and can be used for drinking, not to use for these other functions. So green roofs have been used for that. Just a few examples. They are installed everywhere in the world. This is an example of Japan where it's used to fight water scarcity. So in some parts of the world, it will be for water scarcity, but in some parts of the world where it rains a lot, your most use is to control the floods, especially the urban floods in very highly paved industrial settings. Berlin, if you looked in the internet, is known as the sponge city because they have so much greenery all around, and the main purpose is when it rains, or rains a lot, you can store the water for other purposes, but you delay the runoff, so you avoid the flooding. And this is becoming very important, especially because the urban world population is growing at a much higher pace than what is happening with the rural areas that are actually steady in terms of numbers. So the green roofs, and for those who are aware of that, you might know, you might read the news, in many places of the world, they've been compulsory for new buildings of certain dimensions, especially municipal buildings. You must have either green roofs or solar panels. So you must have solutions to decrease your energy input or your energy use. And green roofs have a lot to do with energy, because in a house or in a setting, in a building where you have a green roof, your energy savings are really big, can be really big if that is well implemented, because you don't have to eat so much during winter and you save air conditioning during summer because they insulate the house. So this is really a multi-purpose construction. And if you look at the original thing, you're actually building them because of the problem we have of highly impermeable cities, where if it rains, the water does not have where to go. So if there are impervious surfaces, what you have is the runoff water on top of your city, and you get. If you have soil and vegetation, the runoff that stays on top is much less. The rest is infiltrated. What's happening in our urban areas, and I'm talking about Porto, for example, most of it is impermeabilized. So you get an impervious surface and you get the floods. So these green roofs have all these multi-purpose functions: rainwater management. They can remove air pollutants. They increase biodiversity, as you've seen for the constructed wetlands, and they decrease the energy consumption. And this has been now studied. They increase the lifetime of the roofing materials. So many of us go through cities with lots of green roofs, but we don't see them because they are on top. And again, they are a nature-based solution because they mimic completely what happens in nature. They mimic the natural soil layers. If you hear about a green roof, it's not just a pot with plants. It's a set of technical layers where you have filters, so the roots do not come through and you don't dirty your water. Then you have the drainage layers. This is also very technical, where you actually are storing the water and you can reuse. Then you have to have this link to other infrastructures. You have a protection layer for the building, and then a waterproofing. So it's not just putting plants on top of a building. If it's not a new building, it really needs a careful look at, because you just can't put too much weight on top of the roof, and you must make sure that you're not going to inundate your building and get the water coming into your building. But if you look here at a soil layer, the soil layers, see that it looks like just what happens in nature. And this, as I said, has been used now much more intensive these days everywhere. And the word intensive was not to do with this intensive that is written here. You can find different types of green roofs. They go from intensive to extensive. And the word here, intensive, it means that it needs maintenance. So it depends on the purpose. If you want a green roof where people can go and walk and see trees, and to be a zone for recreation, then you're talking about roofs with higher depth and more intensive in terms of maintenance and the installation. Then you have the semi-intensive, already a lower depth, and then you have what we call the extensive ones. The example I'll give is extensive. They're just there to serve these purposes of keeping water and all the other services that we talked about, but not for people to go there and walk through, or just to be there. But all of them, they must have all the layers I talked about. If you look at some figures, the stormwater volumes, the flooding, they can be reduced by 85%. So it is really, really a lot. Of course, this is just a drawing. You can have this type. It's okay. It takes much more in terms of installation and operation, maintenance. They do exist, and people are looking very much at these solutions in health buildings, hospitals, for people to get better with nature, not being just in buildings with for health related in terms of technical health solutions. So here it's in this picture you see very well. If you have a peak of rainfall in a conventional roof, you have the water coming through immediately, a very big peak. A green roof, you delay. It does not mean that water is not going to come through. Of course it will, but through time and with lower peaks. That is what is called the flood retention and the delay of the peak. This, I would say that for many places in the world, that's why they're used, to control the floods. Because sometimes they don't even take the water to, they don't even reuse the water in the building. That needs for some other infrastructures. There are some, you can get more in terms of literature, in terms of the percentages of water retention. This is a study of ours, and we got 30%. It was a very, if you see here, 10 centimeters, a very low depth of water, of roof, but in other studies you can go higher, up to 90% water retention. So let me just go this one, just to show some, because you don't get to see them. You just look, there is a prize for the green roofs every year. You can see the best pictures. You can go to a site and see which ones were the prize winners. And what cities are doing is that they are trying to put them in very emblematic buildings, so to be used as a model. So there you go to the New York police station, they have a green building. You put in libraries all over in very emblematic. This is a library actually, this is in Vancouver. This is in, where is this? It's another library as well. Seattle Public Library. If you go to Delft, they also have, it's not here, it's also the libraries, they have a very nice one. So when you see this, it's not just plants growing on top of a building. They really need all those technical layers to keep it functioning, otherwise it will not go. But you have, in USA, you have a lot in very emblematic buildings. This is not an emblematic building, but this is our own ones. This is our facility, our old facilities at university. We moved facility 1 year ago, and this is our old one. We bring in the infrastructures to the new building. And what you see here, this is for research. We use green roofs. We study different substrates, because at the moment, at least in Portugal, to put a green roof, you only have 1 or 2 companies. The materials come from other countries, so it's very much, I would say it's expensive. You need to put this, so you need other solutions. So we're looking at other materials that allow for low weight and plant growth. And we only look, in our case, with aromatic plants. There are native plants here that can survive the harsh conditions of top roofs, especially in the winter. So these are our roofs. They don't look like the ones I've just showed you. We put it with aromatic plants, and we do the studies on the rainwater retention, the different substrates we use, and we do with the engineering school, we do the studies on the thermal insulation of these kind of constructions when we use the aromatic plants and the different substrates. We use expanded clay, we use eggshells, and some more available materials from our country, even what comes from the quercus, oak. What comes from oak? Now I forgot the name. we use what is the stoppers for the winery, for the natural stoppers for the wine. Cork. We are the biggest producers of cork, so we also use cork because it helps insulating, and if it's put in small pieces, it also allows for the drainage of the water. So aromatic plants grow very well. We have them for about 6 years, also in our university, and we did some experiments, not in these bigger settings, but in 1 cubic meter. This is very low tech here. This picture, 1 cubic meter kind of containers for chemicals that were washed and given up to us, and we had an experimental setup. Now it's been more than 1 year. We're confirming for more years to allow for us to calculate what is this runoff coefficient for the water in our Mediterranean climate. So we got this into models, and we have now, wait, I'll come back to this one. We have now it was out this year, a guide. This is in Portuguese because we used to have the German guidelines. We followed the German guidelines. They were the ones that have this really developed. So coberturas verdes mean green roofs, technical guide for Portugal. And our pilot study at university with this 1 cubic meter containers all in series with different plants, getting to collect water for 2 years. They incorporated our model equation into the modeling for the green roofs in Portugal, which was quite nice. And this is also very good to involve students. Students are always helping through our what we call research club. The undergrad students, the first cycle and second cycle can go, and those that really like fieldwork help in this kind of studies, and then we get them the recognition for that they can take to their job interviews and when they go out to work. So these are two of the nature-based solutions that we are using and doing research on. This one, the green roofs, much more recent one, maybe 8 to 9 years. Constructed wetlands, we've been working with it since the 90s, so it's much more experience. But we're trying to contribute to the policies, the urban policies. If we can help, then it's a gain, because the way it's going, especially those people that live in very densely populated urban areas, we have to do something about it. So this is a small contribution, but it's not only research. We use this a lot to get awareness of to get demonstration and awareness of the population in general, with visits to the sites, to the tourism house, and to teachers of the secondary schools that can get to incorporate this in examples. People from schools that come the students come to visit as well. So it's like an experimental model for different things. And we keep it, especially constructed wetland. We're not publishing on constructed wetland anymore. We just use it for demonstration purposes for different levels of the society. The tourism house use it as they do a lot on sustainability, solar panels, biological production of food. They do a lot, so they use it also as a kind of a marketing example of the good practices in terms of environment. So there's a win-win situation. Okay, but I'll stop here. These were the case studies I thought I would bring on these nature-based solutions. I hope they were any use to you. If you want to ask something, I am available to any question. Sorry, I just looked at the time now. I took a bit, 50 minutes. I thought about 10 minutes less, but I got enthusiastic. Thanks for listening. If you have any question, please go ahead.
No question, but for me, it was very interesting and useful information. There were the project for Gyumri last years before the coronavirus, Green City.
Yeah.
And the city government will do it.
Yes.
I hope it will be okay.
Yeah.
But I want to inform you that in Armenia have a beautiful biodiversity.
Oh, I'm sure. Yes.
And these years, I showed that the insect it's diminu. I think that method can help also.
Yeah.
Obtaining very well biodiversity.
Yes.
I think.
Yes, it's not only the plants, the pictures that I show where you see also the insects coming, and it's nice. It's not just biodiversity in terms of plants, it's also for the animals, let's say.
Yeah. Thanks a lot, Paula. Thanks.
Thank you. Thanks for your comment. I don't know if...
Thank you, Paula, for a very interesting presentation. It was really very, very interesting. And as Angin mentioned, in Armenia, we now give a priority for the greening economy and greening of everything what is connected with improving sustainable development in Armenia and this part. And of course, your sample related to the water examples also was very, very interesting and very useful information. Thank you so much.
Yeah, I think I showed the water, but I think it's not only through the water that we convince people, because it's not only water. It's water, is energy, everything is related, it's biodiversity. So
but
it's like...
for you, it was very difficult to present all possibilities and all approach related
to yes, it's very difficult. I think I was saying, I know you were here last time, about water. It's very difficult to say, okay, let's do all this to collect water, and they say, oh, why? It rains a lot in Porto, we don't need to save the water. But it's not only water, it's the energy, because producing water takes a lot of energy to produce and to transport, and also the energy in the buildings with the green roofs. It's really a benefit. In Germany, there are studies that say 70% savings of energy. Even if it's just 30, it would be okay. Even if they are wrong by 50%, it depends on where you are, of course. It's a lot of savings. But as I said, we do not use so much this for research nowadays. It's more as a flag or the model to show people that more the society in general, not so much the scientific research. Yeah.
And related to the urban trees, what about Angin also say about the Gyumri, it's a really big problem in Armenia related to the urban trees benefits. People mentality need to be increased in order they will be understand this issue.
Yeah,
some lecture in the classes for the students in the school, we always say that there are 5 big benefits. First of all, cool of the air.
Yeah. Yes.
Filter urban pollutants.
Yeah.
Increase property values. Increase urban biodiversity.
Yes.
Improve physical and mental health, which is nowadays very important.
The part for the mental is very important.
Yeah.
I didn't bring it here. We have a project. It's still going. It's one of the biodiversity call. It's with Belgium and France, where we're looking at urban trees. It's called the Urban Microserve. We're just looking at the same trees in the trees in Strasbourg, Leuven, and Porto. We have the trees with sensors to monitor the growth, and we through different temperature is online. So I think it's every 2 minutes it grows, it measures, and we relate that with the soil pollution because we have metals, and we relate that also with the ectomycorrhiza biodiversity in the soil, because we're looking at places where they have planting in box, the box system, and at least in Porto, in some streets, and also in Strasbourg and Leuven, the trees are very much exposed to stress because they are in these boxes that do not have so much soil and very low biodiversity. And we're looking at tools. We actually work a lot with Inocula. You will hear about that in the next two, but not this particular project. We introduce ectomycorrhiza mushrooms to trees in the city to see whether that can improve the health status of the trees, because the trees there is many problems with the health of the trees in the urban environments due to stress as well.
Yeah.
But the benefits are the same, as you said.
Sure. Thank you.
Thank you.
Okay. I don't know if you, Zoe, you are the manager.
Since there are no questions.
Okay. Thank you for your attention, for being here.
Thank you too.
We are looking